So in this video lecture, I would like to discuss about Sieve of Eratosthenes. Eratosthenes was a Greek mathematician. He was a Greek mathematician and who was born around 325 BCE. Okay, so he was a Greek mathematician, very great mathematician, and born around 325 BCE, and he gave this method that is called Sieve of Eratosthenes, and what it does is it filters out all the prime numbers. I mean, if you are given some set of numbers and it is asked that okay, find out all the prime numbers out of those sets, then using this method you can find it out. Now you would say that hey, we have learned about prime numbers and we know that how to check whether any number is prime number or not. Then of course that is correct. So example, if someone asks you whether 22 is a prime number or not, so you would say that hey, we can write it as 1 times 22, and then we can write it as 2 times 11, right? Is there any other way? No, there is no other way to write this. So there are total number of 4 factors for 22. So of course you know that for any prime number there should only be 2 factors, that is there should be 2 exact divisors of that number, that is the number 1 and that number itself. But if there is more than 2 divisors or factors, then that number is composite numbers. So in this case 22 is not a prime number. But if someone asks you whether 5 is a prime number or not, you would say hey, of course 5 is a prime number because there are only 2 factors possible, that is 1 and that number itself, that is 5. There are no other factors possible for 5, therefore 5 is a prime number. So if you are asked to check for any number, then you would go that and then you will find out the factors, and on the basis of that you would tell that okay, this number is a prime number or not. What if you have some quick way to find out the prime numbers, and suppose you're asked here that you have to find out all the possible prime numbers in between 1 to 100. So in this example we are just taking between 1 to 100 because at your level you would be asked only between 1 to 100. Otherwise you can find out, I mean, between any set of numbers using this method. Now what does this method has, you should keep some points in your mind before proceeding towards the method, and that is any number which has 0. So point number one is let me do this like that. Point number 1 is that if you have any number which has 0, 2, 4, 6 or 8 at the units place, if these digits are present at the units place, then that number is divisible by 2. That is 2 would be the factor of that number. 2 would be the factor of that number if at the units place you have 0, 2, 4, 6 or 8. For example, if someone says that okay, 36 is 2 is the factor of 36, you would say hey, of course 36 is divisible by 2 because it has 6 at the units place. Similarly for 72, similarly for 74 and 54, like that. Second point is that suppose you write 2 times 13 is 26, right? It's 26. Now you would say that hey, 2 is the factor of 26, 13 is the factor of 26, 26 is the multiple of 2, 26 is the multiple of 13. Now you take any multiple of 26, like if you say that hey, 26 times 2 would be 52, then 26 times 3 would be 78. Sorry, it's not 3, it's 2. 26 times 2 would be, my bad, it was correct. I'm really sorry. 26 times 3 is 78, right? So 26 I have taken 2 multiples of 26, that is 52 and 78. Now if 2 and 13 are the factors of 26, right? 2 and 13 are the factors of 26, then 2 and 13 would be the factors of 52 and 78 also. And you take any multiple of 26, any multiple of 26, like even if you do 26 times 4, 26 times 5. So all those numbers which you will get that are multiples of 26 will be are divisible by 2 and 13 also. Therefore 2 and 13 would be their factors also, and it is true for any factor and it is true for any multiple. Point number 3. Point number 3 is, suppose you write 3 times 1 is 3 and 3 times 2 is 6. There's nothing special that I'm going to tell because we have already covered these points in our previous video, but still I'm just reminding you that okay, these are some points that you should keep into your mind. 3 times 3 is 9. Now you would notice that between every multiple, that is 3, 6, then 9, then again 3 times 4, this is 12. Now you would notice that between every multiple there is difference of 3, like 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. So these numbers 3, 6, 9, 12, these are all divisible by 3, that is these are the multiples of 3, right? They have a difference of 3. Similarly for 7 also, like if 7 times 1 is 7 and 7 times 2 is 7 times 2 is 14 and 7 times 3 is 21, right? So these 7, 14, 21, they will also have difference of 7 in between them. They will have difference of 7 in between them. They will have, and here they had difference of 3 in between them. So I mean, these are the very basic things that but still I'm revising it. And then the last point, that is point number 5, that for any number to be divisible by 5, it should have either 0 or 5 at the units place. For any number to be divisible by number 5. So if you are given like 60, if you are given 65, you are given 75, you are given 95, and sorry, not 98, 95. So if it's asked that are these numbers divisible by 5, you would say of course all numbers are divisible by 5 because 60, 65, 75 and 95, they have either 0 at the units place or they have 5 at the units place. So any number which has 0 or 5 at the units place would be divisible by 5. So these are some of the important points that you should keep into your mind. Now let's move towards now the method of Sieve of Eratosthenes, that is the method. And if you're asked now between 1 to 100, find out all the prime numbers possible. So keep in mind all those points we have just discussed just short back, and using that we will find the numbers. So you know that 1 is not a prime number. 1 is a unit amount and we know that 1 is not a prime number. We don't consider 1 as a prime number. So the first prime number would be 2, right? It would be 2. 2 is a prime number. Now if 2 is a prime number, then all the multiples of 2 would not be a prime number, because now if they are divisible by 2, then they will have more than 2 factors, and if you have more than 2 factors for any number, then that number is not a prime number. So all the multiples of 2 will not be a prime number. 2 is a prime number, but all the multiples of 2 would not be a prime number, because in that case they will have more than 2 factors. So what are the multiples of 2? So you would say that, hey, if any number has 0, 2, 4, 6 or 8 at the units place, they are all divisible by 2, and therefore 2 would be the factor of those numbers. So using that, you cross all those numbers. You cross all those numbers which are divisible by 2. So 12, 22, 32, 42, 52, 62, 72, 82, 92. Why we did that? Because these all numbers have 2 at the units place, so they are divisible by 2. And then we have 14, sorry, we have 4 also. We have 14, we have 24, we have 34, we have 44, we have 54, 64, 74, 84, 94. Then we have 6, and we have 16, 26. You just go on crossing all those numbers which have 0, 2, 4, 6 or 8 at the units place. You just cross all those numbers. all these numbers which have been crossed are not prime numbers because they will have more than 2 factors. Now, which is the next prime number? You would say that, hey, 3 would be the next prime number. Of course, 3 would be the next prime numbers. Now, all the multiples of 3 would not be a prime number. Reason? We know that it will have more than 2 factors. So, what are the multiples of 3? Go on adding 3. We saw it here, right? We saw it here. That if difference between the multiples of 3 would be 3, difference in the multiples of 7 would be 7. Now go on. So 3 plus 3 is 6, it's already cut. 6 plus 3 is 9, just put a cross on it because that would not be a prime number. 9 plus 3 is 12, it has been already crossed. 12 plus 3 is 15, put a cross. 15 plus 3 is 18, has already been crossed. 18 plus 3 is 21. 21 plus 3 is 24, it's gone. 24 plus 3 is 27, it's gone. 27 plus 3 is 38, already gone. 30 plus 3 is 33. 33 plus 3 is 36, already gone. 36 plus 3 is 39. 39 plus 3 is 42, which is already gone. 42 plus 3 is 45. 45 plus 3 is 48, which is already gone. 48 plus 3 is 51. 51 plus 3 is 54, already gone. 54 plus 3 is 57. 57 plus 3 is 60, already gone. 60 plus 3 is 63. 63 plus 6 is 66, already gone. 66 plus 3 is 69. 69 plus 3 is 72, already gone. 72 plus 3 is 75. 75 plus 3 is 78, already gone. 78 plus 3 is 81. 81 plus 3 is 84, which is already gone. 84 plus 3 is 87. 87 plus 3 is 90, which is already gone. 90 plus 3 is 93. 93 plus 3 is 96, which is already gone. 96 plus 3 is 99. So these were all multiples of 3, and any multiple of 3 would not be a prime number. What next? Is 5 a prime number? Yes, 5 is a prime number. Now all the multiples of 5 will have 0 or 5 at the units place, and all the multiples of 5 will not be a prime number, so you have to put a cross on it. So 5 and 2, go on checking. This is 10, already gone. Then you have 15, gone. Then you have 20, gone. Then you have 25, put a cross on it. Then you have 30, gone. Then you have 35, put a cross on it. Then 35 plus 5 is 40, gone. Then 45, then 50, gone. Then 55, then 60, gone. Then 65, 65 plus 5 70, 70 plus 5 75, plus 80, gone. Then you have 85, gone. Then you have 90, then you have 95, and 100, it's already gone. Now, is 7 a prime number? You would say, hey, of course 7 is a prime number. And just similarly check for 7 also. So all the multiples of 7 will not be a prime number. So 7 plus 7 is 14, gone. 14 plus 7 is 21, gone. 21 plus 7 is 28, gone. 28 plus 7 is 35, gone. 35 plus 7 is 42, gone. 42 plus 7 is 49, so put a cross on it. 49 plus 7 is 56, gone. 56 plus 7 is 63, gone. 63 plus 7 is 70, gone. 70 plus 7 is 77, put a cross on it. 77 plus 7 is 84, gone. 84 plus 7 is 91, put a cross on it. And 91 plus 7 is 98, which is gone. Okay, now what next? Is 11 a prime number? Hey, of course 11 is a prime number. Now you can check for all the multiples of 11. 11 plus 11 is 22, gone. 22 plus 11 is 33, gone. 33 plus 11 would be 44, gone. 44 plus 11 would be 55, gone. 55 plus 11 would be 66, gone. 66 plus 11 would be 77, gone. 77 plus 11 would be 88, gone. And 88 plus 11, 99, it's also gone. Next number is 13. Is 13 a prime number? Yes, 13 is a prime number. It's only divisible by 1 or 13 and no other number. So 13, then plus 13 would be 26, and 26 plus 13 would be 39, gone. 39 plus 13 would be 52, that is gone. 52 plus 13 would be 55. 65, gone. 65 plus 13 would be 78, that is gone. 78 plus 13 would be 91, 91, that is gone. And 91, therefore plus 13 would be out of our range. So if you go on checking like this, so what you're left is, now it's for sure you're left only with the prime numbers. I mean, you can check for all numbers, but this is the only way to proceed, and therefore now you can circle all the other numbers that would be prime number. So 17, is 17 a prime number? Of course 17 is a prime number. Is 19 a prime number? Yes, of course 19 is a prime number, because it's only divisible by 1 on 19. Similarly for 23, and then 29, and then 31, and then 37, and then 41, then 43, and 47, and then 53, then 59, 61, 73, 79, here you have 89, and here you have 97. So these are all the circle numbers are all prime numbers, and the numbers which have been crossed are not prime numbers, and 1 is not a prime number. We know that 1 is a unit. So if you're asked to find the prime numbers in between any given set of numbers, then this would be the way to find the prime numbers. Like, first start from the beginning and then just cross all the multiples of that particular number, and you'll just get the result. Okay.